Okay. Okay. So how did you guys do make out with the properties, like doing first name, last name? Those work out okay? Okay. If you guys don't answer, it means it's okay. I don't know. It's a matter of you guys. Okay. So to easily add something like first name or last name, um, to do that properties like we did the other day, we're on like gender, so it could come here, first name, and then it's a string. So you just enter that in, and then you want public, and then that's it. We're good. If we want to put in the last name, so we put the name of the property in. It's a string again. It's public, and then that's it. Okay. When we go down here, what are you guys talking about over there? Holy smokes! I don't care. Can you not whisper? Like this stuff's not like easy to do. Like I gotta concentrate too, and I can't concentrate if people are all talking behind my back. So it's gonna automatically put those items in, first name and last name. So you can just use the tool real easily. But we need a variable to do the data abstraction with, right? So we wanna put a variable in, and then these methods will encapsulate that variable. So the only way you can get access to it is through these properties, right? So we'll go back here where our data members are. We'll create a private. So you should have done a private and a string, and then we call it m last name, and then private string and first name. So you should have did something like that. Like I said, we had a whole list of them to do. Maybe I'm not going to implement them all. And then to get the first name and last name, well, so then we'll to get it, we'll say the m last name is going to equal value. No. Oh, that's first name. Sorry, m first name. What's going on here? Oh, I'm doing it in the wrong one. That's why. Sorry, the set the value. There we go. Value, and then the get we use the return, and then m first name. Again, if it's read only, this set or this mutator goes away, and you can just like comment that out. And then we'll do the same thing for this one here. So we'll do return m last name, whatever stored in that variable, and then m last name equals value. That's the one that it's set equal to when it actually gets used, right? That's the keyword that C# uses to pass it in. Right? So there's other ones too. Employee. Maybe we'll just add the employee number in. Okay, so like those three there. So if I go back to properties, maybe I'll just add the property here. We'll do employee number. I'm just going to call it employee number. Yeah. It's going to be an integer, public. That's good. So we're all good with that. Yep. It's going to be a number. And this way maybe it makes it easier when we put things in alphabetical, or like if we want to order them by their numbers or whatever. So in that case I'll use it as a number. Sometimes you might store it as a string. Depends on the data. I said this one five digits, so we could use it as an int. It'll store it, no problem. So then we can just return. Oh, and we need the variable that stores it, right? So we'll come back here, private int, and then m employee number. I'll use a little abbreviated form of that variable there. And then we'll do m employee number. Just like that. So now I got my first name, last name, employee number. Gender we already did. Regular hours, overtime hours, salary, pay rate. You do all those in the same way, right? Pay type, maybe you did another enum to add those things in. Okay, so I just gave a whole bunch of those things to you so that you can practice creating them, right? So we don't even need properties for some of them, maybe. Okay. Now, when it comes to the methods, one of the things that I wanted you to make sure that you can play around with is using a method inside a class and using it in one method. You create it, but then you also use that method in the same class, and how we would get access to it. And I said you would just use its name to get access. So let's say I'm going to create a method for regular pay and overtime pay. I'm not going to use the properties. If you did, that's fine. But I'm just going to create those methods just to show you how we could create two private methods. They won't be exposed to when I create an object out of this class. So when I in my form, I want to use the methods or properties. Those won't show up, but I can use them inside my class. So what I'm going to do here is I'm going to create a private method, and it'll return a double for the regular pay. We'll call it regular pay. We'll put a double in for the hours, and then we'll put a double in for the pay rate. So whatever the pay rate is and whatever the hours are, and then that will calculate the actual regular pay. So we need how many hours they work and then what their pay rate is, right? I mean, you could just watch what I'm doing right now and then just take the video. I'm going to give you some time to just do it. So you could just follow what I'm doing here and take. I'll do the video right away, and I'll give you guys a little bit of time to. You can implement it with the properties if you want, or just do it this way. So, so you could just follow along. So, and then over here, pay is going to equal the hours multiplied by the pay rate, right? And then I want to return that. Okay, so my regular pay gets stored in this value, and it matches the data type there because it's a double, and it'll get returned. But it's private. So if I go into my form, and I do, we used Ivan's name, Ivan dot. So we have get type, we have employee number, first name, that shows up. But notice that the regular pay did not show. Didn't show up because it's private. Okay. So I'll go back here. I'll do another one, private, double, and it's going to be called OT pay, overtime pay. Maybe we'll write it out, overtime pay. And then you're going to put in double, again, double hours, the hours that they paid, and then double pay rate. OT pay is going to be the hours, and then when you do overtime, they get multiplied by 1.5 times the pay rate that comes in, and then we return that. And again, if we were to go in our form, put our object name in there, put the dot after the period, you'll see that because this is private, that doesn't come up. Right? But I have this paid. So what I'm going to do is I'm just going to update this. So if a person wants to get their pay, they would if the person wants to get their pay, so we're going to update this. You need the regular pay hours, you need their overtime hours, and then you need the pay rate. So you need those three pieces of information. So we'll say regular hours, right, as an input. So we're going to just change it, and we're going to do double, and we're going to have overtime hours. Maybe we'll just put OT hours, and then we'll do double pay rate. So we're passing in those three pieces of information: how much regular hours they worked, how many overtime hours they worked, and then what their pay rate is. So when we want to calculate their pay, it's the addition of their regular pay plus their overtime pay, right? So we already have methods that do those calculations, so we're not going to do them again. We'll use those methods inside our own class that we have. So I'm going to take all this out. So what I would do is I would just call up, what did I call it? Regular pay. Regular pay. You would call it regular pay, and we would put in regular hours. No. Come on. We'll use that variable, and then we'll do pay rate. That's passed in. And then we'll add that to the overtime pay method. So all you gotta do is you just, so whenever there's a method inside a class, you can just use it by just calling its name. I don't have to create an object for it. I've had students do that in the past, right? But you're in that class. It's part of it. I have access to it. I don't have to create an object called employee inside here and then to get access to those methods, right? They're inside. So anywhere, whether they're private or whether they're public, I can get access to any of the methods. Private, public, doesn't matter. They're available to the class. And you just call them by their name, right? And then plus overtime rate, and then we'll put OT hours in there, and then pay rate. Right? So it'll be the person's pay is going to be their regular pay plus their overtime pay. And then I pass these in. Now in yours, I mean, you might have put in those as properties. So you don't need to pass them in, right? And internally you would just use the properties to pass in. So I mean, if I didn't put these properties in, okay, or if I did in this case put the properties in, I wouldn't ask for these because those would be stored as properties, right? The values would be in there. So when I call pay, I don't have to pass it in. I would call regular pay, and then I could use the data fields, M regular hours, M overtime hours, right? Because those properties would assign those values. Okay, but I do have access to these, right? And then you just call it by its name, right here. So when this gets called, it'll go over here in the code and run everything. When the overtime one gets called, it'll go inside the same class and find the code in there, and it runs it, and then these two are added together because they both have return values, right? They both do a calculation, and then that's it. And when I go and I try to use this, so let me see if I can run it. I have an error, so let me see what it is. So my pay is no good anymore because I have regular hours. So if the person worked, let's say 20 hours, and he worked, let's say 5 hours of overtime, and their pay rate is $10.50. Okay? So it should be 20, let's do the calculation. So their total pay should be 20 times 10.5, right? That's $210, right? So 210 plus, and then we got to do the other one here. So it'll be 5, but they get paid an hour and a half more. Every hour you work of overtime is really worth an hour and a half, right? So really, in the end, you worked 5 hours of overtime. Maybe they got that because they worked on a Sunday or something, or it was a holiday or something like that. So then that's really 7.5 hours they worked, even though they worked 5, right? So they got time and a half, and then you multiply that by 10.5. So it's $78.75 plus the 210. So their total pay should be I'm going to write it down, $288.75 for working that week. They got paid the regular hours, then they got paid for their overtime. Make sense? So if I run this, that's what I should get, 288, unless I made a mistake somewhere. So I'm going to put a little breakpoint there to stop it. We're going to run it. I hit OK. All that gets passed in. Let's follow and see where it goes. So I'll step in. So it's going to come here. It's going to read in my regular hours, and there's my pay rate. So if I step into this, it's going to go into the regular hours method. It's going to calculate that, 210. Right? Comes out 210. I keep going. It's going to go into the overtime one because those two are added together, right? So it just took them in order, right? It's going to come in here. My overtime pay, 78.75. They've worked that out. I put my mouse over top of here so I know it's working out. So far it looks good. And then it's going to add those two into pay. So 288.75 comes up, right? And then that gets now stored in this variable out here. So I could use it, right? I went from one class to the form, and then it went to the other class, did everything, returned its results. It's stored in here now, and I get to use it over here. This gets to go away in memory. It's done. Except for the global variables, right? While this Ivan stays alive, right? Until the end, right? And then, well, we're outputting the gender, so it's not going to work. But my pay is 288.75, and I did a quick test. Okay, so a lot of time when I would be coding for whatever company, all my projects or whatever, I might not even have a chance to output something on the screen because maybe I'm not even working with the user interface. Maybe I might be working with something that another person is going to take my code and then display it on a web page. I don't know what they might be doing. So I would run my code and put breakpoints in, do all the calculations, maybe in a form, and then just trace through and make sure I get the answers that I would expect, depending on, and I try different types of inputs, and then that's it. And then I say, okay, it's good. I'm done with this part, cross it off my list, I move on to the next part that I want to start coding, right? But you got to test it out, right? So you're kind of following that cycle. If something doesn't work out right, look at your logic. Maybe you made a mistake, or look at the requirements. Did I do it right? Why am I not getting what I expected? And then you could go ahead and start correcting things. So here I have one class interacting with the other. The one class is doing all this work. So really what the form class does is it doesn't do anything. It just gets user input and outputs to the user. All the logic, all the smarts, bless you, all the logic, all the smarts is happening where? Where's all my code, all the calculations, all the intelligent calculator, where's all that happening? Yeah, which one? Where's all the smart stuff going on? Which class? Employee. Employee is doing everything, right? All form is doing is accessing inputs, right? Calling employee class, and then getting the results from employee class to display to the user. But all the processing, all the intelligence is actually in the employee class, right? The form is just now really just to support my graphical interface and my outputs, my inputs, my outputs, right? For displaying purposes, really, and giving the person a means to interact with the computer through that interface. But really, all the smart stuff is going on in the employee class. It's doing all the calculations there, right? So we have a nice separation of code, right? I got my form class, which takes care of my user interface. and all my inputs and where I'm going to output things, right? And then now I have my classes, my other classes, such as employee and maybe any other ones that I put in there to take care of all the logic and processing and the, right? So now I'm already starting to separate code into different kind of tiers in a way. So you could look at code in the different tiers. You can, so basically what we have here, well, I could try the notepad again. So basically what we have here is we have a graphical interface tier. That's my form. If I had other forms, they would all go inside there, right? And then I have, you can start thinking of a business logic tier, right? So this business logic tier is where classes such as employee would reside, because that is all the logic for this particular application. And then you'll commonly see one other tier, which we're not going to get into in this particular course in any detail, that's for sure, would be like a data access tier or a data tier. So your kind of program is broken up into kind of like different parts. Graphical interface, business logic, and then a data tier. And this data tier is used to access the data. So there would be all kinds of classes and components that go out and get access to the information that you need. It could be a file. Most commonly it's a database. Supercharged database like SQL Server or MySQL or Oracle database, right? You go out and get all that information, right? I would use the business tier or the business components or business, we call them business objects, to access, to do all the calculations. It will probably most likely access the data objects, which goes out and gets the data from somewhere, and then they come back, and then I use that data to do something with it, right? So you kind of break it up into three tiers. They call this, you could have a three-tier solution, and you can put all these components on three different types of machines. So what I can do is I can create a, so let's say I'm going to have lots of people accessing my system, so you won't be able to handle the loads properly. So what you'll do is you'll put like your user interface, like let's say it's a web pages, those will all be on one computer, and that's your web server. Then we'll have a separate computer which will store all these so-called business components, right? And all those business components will have classes such as employee that do that follow all the rules and calculate, do all the processing and calculations. And then you'll have a third machine that has your database on it. And maybe your data tier objects might even be on there too. Sometimes they take those out and put them where the business ones on them, right? So you have three computers, three tiers, right? And then what I could do is I could have 2 or 3 dedicated computers for the web interface, 2 or 3 computers for the business components. Typically, you only usually have one for the database. You might have more than one hard drive, because now you can split up the database on multiple drives. It becomes a problem with data saving. So as soon as I save data, if I have more than one machine, it's got to replicate it automatically. It becomes very complicated with databases. So usually you got pretty fast database server, right? And this way I got 3 tiers, and they're all and you'll have like a network specialist usually working on those 3 and setting those up. So if one of the computers goes down, it doesn't matter because I have 2 or 3 of them. So we used to have like at least 2 for each tier, except for the database. The database comes backed up every day, but it was always nerve-wracking if that thing ever went down. So 2 or 3 computers for each tier, except for the database. One computer went down, didn't matter, because the other ones will just work a little bit harder. Maybe a hard drive went dead. Pop the new hard drive in. Once that thing goes up, then it starts to share the load. So if you got lots of people coming to your website and accessing all this logic and everything, the processing power gets distributed amongst the different computers. Makes things kind of seem like they run faster. You just have more computers running to process everything, right? So with object-oriented design, you can start to really break things up into little pieces too. You can even distribute it across multiple PCs. Don't worry, I won't test you on that. That's just for kind of fun. That's just kind of how it works out there for most solutions. Okay. But that's why it's important to kind of understand these, you know, these object-oriented concepts, because it'll help you. So for me, right now, I want to make sure. How about creating properties? So do we have a good understanding of what that is? I mean, the tool could do it easily for us. Do you guys get a good grasp of what that means? Right? So all we're doing with the property is we're hiding that variable, right? Private variable that stores the value. And then we use the property to ensure a proper value is being assigned, and we can put any restrictions on it if we have to. None of these had any restrictions, but we could have easily done that. So those are okay? You guys okay with the methods? No? Maybe? What's that? Sorry? I just can't hear you with the fans. Want a little more practice? Now I gotta give you a little something to do where you can create a simple little class. I want to make sure you can do these. Why don't we? Should be easy for some of you in the second semester. Why don't we just create a shapes class where we'll do something like a pick a good shape so the calculations are a little bit more fun to do. What's that? How about a cylinder? You could have a surface area of a cylinder, and you could also have volume. So you have to look it up. I don't know off the top of my head. So why don't we create a class? We're walking around in circles. Okay. So create a class called shapes. And then in this class, you're going to create a cylinder. Okay. Why don't you do a cylinder and a sphere? So put two in there. I want you to create two classes in, right? We can put every single shape in here if we wanted to, okay? So create a cylinder. You got to look up the cylinder. I want you to create the surface area and its volume. Okay, why don't we call this 3D shapes? So we only put 3D shapes in there. So for the sphere, I also want you to calculate the surface area and the volume. Okay, in these particular cases, when you do the sphere, I want you to implement properties. When you do the cylinder, there's no properties. Okay? So when you create the cylinder, there's lots of different ways you can do this. You could put a constructor in the cylinder and ask for its radius. I think you need radius and height. Does someone look up the cylinder real quick? Just radius and height. Those are the only inputs. So with this one here, with the cylinder, create a in the constructor. Okay, you ask for the radius and the height. Because I have the radius and height, do I need to ask them over here now? When I create the cylinder, I give its radius and height. So when I call for the surface area and the volume, do I need to ask for it again? No. Okay? You can do it that way. So that's kind of one way of doing it. This way, for the sphere, all we need is, what do we need for the sphere? I don't know. Someone want to look that up? Is it just radius? I don't know. Someone just double There's a 4/3 pi r cubed. That's the sphere. But I don't know about surface area. Maybe there's an addition. Just radius? So for this one over here, when you create the sphere, don't put no constructor. Don't put a constructor in, okay? But you'll set its radius. You can set it by its property. And then again, you won't need to use these. Well, let me think here. There's so many different ways of doing these things. Yeah, you could do it that way, but then again, you won't ask for it in there. Okay, wait. Here you'll ask for the radius. Here you'll ask for the radius. Here, constructor, you can put the properties here, so then you can change them. So when I do my cylinder, I can use my constructor to initially set the radius and height, but then I can change them too after. And then let's say I have to do 3 different cylinder calculations in a row. I could set one. I could set my initial one through the constructor, and then with its properties, I could set the other 2 cylinders, right? Instead of creating a separate object for it, right? And then call these again. Okay. So these ones you don't need to pass anything in. Okay. This might not be as realistic, right? But I just want you to try different ways of doing things so you get a good handle on how this works. So 3D shapes. This one will have a constructor properties, and then you don't have to pass anything in. For a sphere, you won't have there'll be no constructor, no properties. But anytime you call surface area volume, you have to pass in the radius, right? I could implement this one this way too, but I don't know. It depends like really what you want to do. Both ways are kind of correct. It's up to you how you design it, right? So you would kind of think about, well, what would be the best way of using this thing? And you might be wrong in your first guess. So why don't we do that tomorrow and work on that and then create that? Okay? I'll get you guys a hand and mark it like out of 10. Okay? So you either get it or you don't. Does that sound good?
Pardon this interruption.
What's that?
All conference students, the ones that are coming.
Yeah. No, before.
Tomorrow night after school.
Yeah.
All classes. School. Also for staff, our classes will begin at 3 o'clock in the lecture hall.